Now, I talked in a previous video about how to nitrate benzene. I talked about how you would reduce it off in the end if you want to form the amine. I want to go back to that because it's something I touched on because I want to keep the video focused on nitro functionalization. But let's say we take benzene, and what we ultimately want to convert it to is aniline. Well, there is, as far as I've been able to find, no way to directly do this type of conversion. We actually have to do it through two steps. And the first step we've already talked about, which is with an HNO3, H2SO4, to form aqua regia in order to generate the nitro, what's going to be the nitro intermediate in this reaction scheme. The last step to convert it from NO2 to NH3 is actually pretty straightforward. It's hydrogen gas on top of rainy nickel. So, rainy nickel here is going to do a really good job. It's just a high surface area nickel catalyst that's going to convert the NO2 to NH2. Now, what's the problem with this? Well, hydrogenation reactions, if you have a carbon-oxygen double bond and you do this over H2N, H2 on top of nickel, you may actually end up reducing the ketone. So if we had a ketone on our group, we might also end up with the alcohol. So how do we get around this? There are other options. One option here is an iron HCl catalyst. So if we have HCl and Fe, in principle the Fe cannot reduce this ketone. See, we would still finish with the ketone, but the FeHCl is going to be much more selective to removing the NH2. So this is a second option. If you have a group that is sensitive to hydrogenation catalysts, such as like a ketone, we have the option of using the iron. Now, there are many other options out there. There is PDC, the Lindlar catalyst. The PDC will pretty much ensure that if you have something like an alkyne or an alkene, the alkene doesn't get hydrogenated. You could get this with the HCl and the Fe. The HCl could add to the double bond. Now, I'm not telling you this because I expect to give you problems that complicated. It's just to address that there is synthetic. It's not just the group you're targeting here. With any reaction, hopefully you're seeing with these videos where I talk about subsequently how to deal with the reaction groups. If it's just the nitro group, okay, use the hardest method possible. Use the most aggressive. Use the H2 and the rainy nickel. Why? It's going to have really good conversions and it's going to go really fast. When we start producing more and more selective reactions, meaning that we're trying to target just this one functional group more and more, typically the trade-off is that we lose speed. It's going to take longer and longer for this reaction to go because it's far more gentle. But here I presented you with two options. If you want to go to the aniline, in all cases you're going to have to go through the nitro to reduce the nitro, H2 with rainy nickel, or iron catalyst in the presence of HCl. And that'll get you to the NH2 group.